So we're going to try to find the perfect squares in all of these questions. 125 is 25 times 5, and r to the 13th is r to the 14th times r to the 1. Now why those two numbers are important? Because 5 times 5 is 25, so that's an obvious perfect square. And r to the 7th times r to the 7th is r to the 14th, so also a perfect square. That means I can take the square root of the perfect squares, so 25 and r to the 14th, and leave the other terms which are not perfect squares in the radical. So square root of 25 is 5, r to the 7th, and 5r under the root sign. Here we're looking for perfect cubes, so 108 divided by 27 is 4. So cube root 27 times 4, and x cubed times x squared. Now why those two numbers? Because 27 is 3 times 3 times 3, so it's a perfect cube, and x cubed is x times x times x. So I'm going to write them in two separate radicals, one containing the perfect cubes and the other containing the non-cubes. So cube root of 27 is 3, cube root of x cubed is x, and we have got the cube root of 4x squared remaining in the radical. Now fourth roots, so we're looking for the numbers that are multiplied to give you, 4 numbers that multiply to give you a perfect fourth power, and that's 16 times 3, y to the 4th, y squared. Now why these numbers? 16 is 2 times 2 times 2 times 2, 4 2's, and y to the 4th is obviously 4 times y times y times y times y. Writing them as two separate radicals. The 16th, oh, I should have remembered the fourth root here, that's really important. Fourth root of 16, y to the 4th, the perfect fourth powers, and what's left is still under the radical. So the fourth root of 16 is 2. The fourth root of y to the 4th is y equals, fourth root of 3y squared. Here's your final answer.